And then whenever they are doing some sort of testing, if they're doing a static fire or anything like that, the roads have to be closed, and they need permission from the county. So it's rather interesting. If you go to Kennedy, Kennedy is a really huge area with lots of roads in there, but it's all within the complex and it's managed by Kennedy, and they can do whatever they want. But SpaceX only has property just to one side of a public road. They don't own the road. The county still manages it. And there is a beach where people like to go down to. So every time they close the road, they're inconveniencing the people that would like to go down to that beach. So there is an agreement with Cameron County to say, okay, you can get so many road closures, but you can't do it on weekends. And then it's like, well, 5 weekends a year, we'll let you close it, but we really don't want to. Now, SpaceX has not done a weekend closure yet that I'm aware of, because I think they're holding them for the launches. So if they need to move the booster up and down, they'll do it Monday through Friday. So the expectation was that they were going to try to launch Friday, and if not, they would go Monday. So it was kind of a surprise.
Okay, wait. Scott, can we listen in?
Yes.
Oh, have they started? Cool.
No, they started the live stream. They didn't launch. Okay.
No. I just didn't know if they'd started the live stream. I heard it was 7:24 my time, but anyway, I guess it just started. I can't hear it, by the way, Herbert.
Yeah, well, we're working on getting that the audio to come up. So the thing about this weekend launch is they have a really short window right now. They have 20 minutes
orbit
between
to land astronauts on the moon for the first time in 50 years, and ultimately to get humanity to Mars.
But the fundamental revolution with Starship is that it's designed to be a fully, rapidly reusable, reliable rocket, or what we refer to as the 4 Rs. For those of you following along, you know all too well that Starship gave us quite a show during its first flight test back in April. After successfully lifting off and clearing the pad, Starship became the most powerful rocket ever launched.
But during the ascent, we had leaking propellant in the bottom of the booster, which led to sustained fires, loss of control, and ultimately a rapid, unscheduled disassembly. Of course, there's no test quite like a flight test, and our teams learned a lot, which began design changes and then ultimately hardware upgrades. That iterative approach is a big part of how SpaceX does development, and it's been the basis for all of our major innovations, including those on Falcon, Dragon, and Starlink.
I have to comment what gorgeous sunrise views we have here of Starship. Now, while that first flight ended in fireworks, it delivered valuable test data, which our teams have used to rapidly iterate on Starship's overall design, including significant upgrades to the ship, the booster, and the ground systems. Now, the most notable change is to the stage separation system, which will also be the most challenging part of today's test. We'll talk a little bit more about those updates a bit later in the webcast.
Now, in preparation for today's flight test, the vehicles have undergone dozens of individual tests, including a static fire on the ship, 2 super heavy static fires, and a final full wet dress rehearsal that we completed at the end of October, where we loaded the vehicles fully up with propellants and tested our new countdown sequences. And that brings us to these beautiful shots on today's flight test day. After 7 months of hard work by the entire SpaceX team, we're ready to give launch another shot.
100%. Now, once again, just like Flight 1, excitement is in the air. The electricity is certainly starting to grow. This is a live view of our Starbase Control Center, known as Star Command. It is 6 miles from the pad. We also have teams gathering here right behind us in Hawthorne, California at our Mission Control Center. You can see the crowd gathering. It is an early morning, but you got to wake up early to get that front row seat. And we also have public gathering on the beaches at South Padre Island, as you see there.
And I can't say this enough, today is a flight test. While it's not happening in a lab or on a test stand, today is absolutely a test. And the goal is to gain invaluable data to continue rapidly improving Starship. So whatever the mission outcome today, excitement is guaranteed.
Now, if all goes well, Super Heavy will fire its 33 Raptor engines and lift off from that pad right there in Starbase. About 3 minutes into flight, we hope to see the Super Heavy booster separate from the ship in SpaceX's first ever hot stage separation. This means that the second stage will light its engines while still attached to a partially lit booster. If the ship's engines light, and if the whole thing holds together, its engines will remain lit for about 6 minutes before the coast phase.
Now, with those big ifs, if we get past a successful stage separation, the booster is going to perform a flip maneuver, then execute a boost back burn before it attempts a splashdown in the Gulf of Mexico. In the meantime, Starship will coast for about an hour at altitudes ranging between 150 and 250 kilometers before it makes its own re-entry into the Earth's atmosphere, and then ultimately a hard splashdown in the Pacific Ocean.
Now, again, if we get past a successful stage separation, Super Heavy will leave the ship at an altitude and trajectory just shy of orbital, meaning Starship won't have to fire its Raptor engines for a deorbit burn and will naturally come back into the atmosphere. Now, meanwhile, Super Heavy will attempt a landing burn before splashing into the Gulf. While the booster will practice a landing, we do not plan to recover any hardware from Super Heavy or the ship on this particular flight. Now, with the exception of Falcon, this really is no different than what happens to most other rockets flying today that are expended or fall into the ocean after completing their mission.
Now, even though we aren't planning recovery, the telemetry and data that we receive all the way to the end of today's mission is really what we're looking for, particularly with respect to temperatures during re-entry and how the heat shield performs. Much like our first test, we want to gather as much data as we can around the fully integrated vehicle in this flight-like environment.
Exactly. So let's talk about some objectives for today. The primary goal for Flight 1 was to clear the pad. We did that, and we got amazing data that helped us to improve the vehicle and pad that you see right there today. This time, on Flight 2, we're hoping to get all the way through stage separation, where we will try to perform this hot staging maneuver. In the bigger picture, Ascent is the most critical objective today, and everything else is learning. Like I said last time, a few times, the further we fly, the more data we can collect.
Now, we do expect that the camera views will be spotty after stage separation, and that's because we rely on ground stations that are positioned along the globe along the trajectory. But we are experimenting with Starlink on both the booster and ship on this mission, which will be communicating with our satellites in orbit to see if we can get that data.
Yeah, so if we make it past stage separation, there is a chance that we could get better live views throughout the duration of the flight test, including re-entry, where we typically have a blackout period with no communication with the vehicle whatsoever. So all that said, this is the first time that the vehicle will attempt to communicate with Starlink in orbit, so no guarantees.
Now, we're at T-minus 27 minutes, so let's check in with John for an update on the countdown. How are we looking, John?
Thanks, Shiva. We're currently loading propellant from the ground system into both the first and second stages, and we're on schedule for launch in just over 26 minutes from now. Now, we delayed a day getting here. Yesterday, on Friday, we had to replace a discrepant grid fin actuator on the first stage. We also replaced 2 other actuators as a precaution. The stages were remated, checked out, and everything was go for where we are right now this morning. Now, as I mentioned, we are in propellant loading. Both vehicles, the first and second stages, use the same 2 propellants. Our fuel is liquid methane at a temperature of just over 100 Kelvin, or about 272 degrees below 0 Fahrenheit. This is a different fuel from Falcon 9, where we use the RP-1 kerosene. But our oxidizer is liquid oxygen, the same as Falcon 9. Because there is no oxygen in space to support combustion, we have to bring our own. We did the weather poll and the go-no-go poll at T-minus 2 hours. We got the goes, and we started loading both propellants on the booster at T-minus 1 hour and 36 minutes. And at T-minus 1 hour and 17 minutes, we began propellant loading of the ship second stage. Propellant loading of the Starship second stage main tanks will complete at approximately T-minus 22 minutes, just a few minutes from now. And at about the same time, we will switch over to loading the header tanks in the nose of the ship. Meanwhile, it'll be T-minus 3 minutes when Super Heavy prop load completes on the first stage. And at that point, all propellant will be on the rocket, fully loaded with over 10 million pounds of propellant. As we near T0, it's worth noting that the timing of the countdown will be slightly different today. For Flight 1, we lit the engines and lifted off about 6 seconds later. For Flight 2, we aim to reduce that time by almost 2 seconds, shortening the period between engine start and liftoff. This will help reduce stress on the ground and the propulsion systems and improve the efficiency of the rocket. Now, right now, we're just inside T-minus 25 minutes to liftoff. The weather and winds are looking good. We haven't had any concerns there. The only issue we're working is getting the small boats out of the near range area in the offshore from Boca Chica Starbase. We do have the possibility of holding at T-minus 40 seconds as we're trying to get the last of the boats out of the safety area. Now, if for some reason we do not make our test flight today, we have a backup launch windows. This could be either 24 or 48 hours after today. It depends on how far we get into the countdown. But for now, everything's looking good as we've passed, coming up on the 24-minute mark. I'll hand it back to you, Kate and Shiva.
Thanks, John. Now, that countdown is continuing to progress, so let's take a look at and get more familiar with the vehicle there on your screen. Starship is the world's most powerful launch vehicle. It's currently currently with about twice the thrust of the Saturn V rocket, and with future engine upgrades, it will be 3 times more powerful. Those future improvements will allow Starship to carry 150 to 250 metric tons to orbit.
Now, for reference, Falcon 9's heaviest payload to date is about 17 metric tons. So we're talking about an order of magnitude more with Starship in terms of payload capability. And that matters because the amount of mass that we're able to launch per rocket is crucial to ultimately creating a self-sustaining city on Mars. Now, let's talk a little bit about how tall the vehicle is. The Super Heavy booster alone stands about 70 meters tall, and that's about the same height as a fully integrated Falcon 9. The height of Starship on top of it is comparable to that of the Statue of Liberty. But of course, the most technical length unit is that of Godzilla's. And we can confidently say that the fully stacked Starship and Super Heavy is at least one Mechagodzilla tall. It just so happens that we refer to the launch and catch tower at Starbase as the Mechazilla from the Godzilla
I just
movie.
watched
And you can
Monarch
see from
last
that
night,
that
so that's
the-
appropriate.
I did
Very
too.
good
quite
timing.
uncanny.
Yeah.
It's a
Very,
great
very
show.
uncanny.
Yeah.
Now, the first stage, also known as the booster or Super Heavy, has a diameter roughly 2.5 times that of Falcon 9, and with 33 much larger engines. More engines means more power to deliver a massive amount of cargo to space. Amazing view here. This is a view that we don't have on our Falcon 9 missions. This is a view looking up under the Super Heavy booster. I love the shot. We can see all 33 engines there. Now, one cool upgrade on the booster's engines, we have a new electronic thrust vector control system, or ETVCs. We previously used the hydraulic system to control the positioning of the Raptor engines, meaning we tilted them in flight using pressurized fluid. Now, hydraulics are complex, and because they're fluid-based, they have the potential to leak. Not good. So switching to an electronic system means fewer potential points of failure. Also, we now carry less mass on the vehicle because we don't need to carry hydraulic fluids anymore. So good news all around. Now, the electric system has lots of benefits on its own. It
Like
only
you have to
takes
carry
30 minutes
batteries.
to activate for flight. It doesn't consume
Or
resources
generator.
when inactive, and they allow for regenerative charging like a Tesla battery.
Yeah, all great things when you're trying to rapidly reuse a vehicle. Now, moving up,
These are
Starship
huge upgrades,
is
by the way,
designed
folks.
for vertical takeoff and landing on any hard surface. That's opposed to taking off and landing on a runway like aircraft do. And that's important because there are no runways on the moon and Mars. The ship features 6 Raptor engines, 3 of which are sea level, and 3 of which are vacuum engines with an expanded nozzle, which makes them optimized to operate in the vacuum of space. The ship, at the top of the ship is featured with 4 flaps as well. This is a shot actually of the top of the booster where we can see the hot
That's
stage
where the
portion
actuators are
and the
failing.
4 grid fins. Now, those flaps on the ship portion help aerodynamically control the vehicle's attitude during atmospheric reentry and flight, and will enable us to do precise landings. The body of Starship is also wrapped in a heat shield that's made up of 18,000 hexagonal ceramic tiles. You can see them wrapping around the top of the nose here and here in this shot of the flaps. Now, those tiles are designed to insulate the vehicle during atmospheric entry, where the temperatures can get as high as 1,500 degrees Celsius. And one of our test objectives today is to verify how those systems perform during reentry.
Yeah, now as Shiva mentioned, there between the ship and the booster, basically the top of the booster, between those two stages, that's our new hot stage, critical for our new separation technique. As we talked about earlier, we are constantly learning and upgrading the vehicle after we test. Now, this is a pretty exciting first for our team, as hot staging has never before been used as part of a reusable space transportation system, let alone on a rocket with the size and power of Starship. Hot staging is a significant change from Flight 1, and we're really hoping to gather data on it during this highly dynamic phase of flight, and that is, once again, assuming that we even make it that far.
Of course, let's take a closer look at what we expect hot staging to look like. Now, it occurs at about liftoff plus 2.5 minutes. At that point, the booster will shut down most of its 33 engines, leaving just 3 running.
Wow.
And the ship will ignite all 6 of its engines. Clamps will release, and then the ship will thrust away from the booster. Now, this is the first in-flight test of the heat shield on the top of the booster and the bottom of the ship, and of course, the first in-flight test of hot staging, and we're hoping to gather a ton of data on it today.
Yeah. Now, stage separation by hot staging is somewhat uncommon in spaceflight, but it has been done before. However, today will mark the first time that a reusable space transportation system is attempting it. The Titan program did hot staging quite successfully in the early 1960s, but they were not concerned with reuse, so there was no issue when the Titan first stage took considerable damage upon ignition of the second stage engine. Now, today, there is a good chance that our booster will also incur some damage from the second stage engines, but we need to test it out, see if the system can tolerate it, and collect data to learn how to do hot staging better next time. Because ultimately, when successful, it could increase Starship's payload to orbit capacity by 10%. So more payload and more people to Mars. Hot staging also helps us maximize the vehicle's performance by leaving those 3 first stage engines on, so gravity can't rob us of precious velocity, or at least not as much of it. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the prop tanks, which is where we need them, which is where we need that propellant to be in order to quickly light the ship's engines. Another reason to do hot staging, it reduces the risk at stage separation by moving to a passive stage by moving to a passive stage system, deleting parts and simplifying, meaning physics is going to be doing most of the work instead of mechanical parts that would otherwise be pushing the 2 stages away from each other.
That's a great summary, Kate. And of course, this required design changes from Flight 1. The most notable of which is the inner stage here. So on Flight 1, that inner stage was completely enclosed. But for hot staging, the interstage portion between the booster and the ship is going to see dramatic increases in pressure and temperature. So we had to change the structure to include vents for the exhaust gases that the ship's Raptor engines will produce. Now, the 3 center engines on the ship actually gimbal, they rotate, and we're going to be gimbaling them outwards to reduce the forces that are being directly imparted on the booster and maximize the exhaust gas that's going through those vents. We've also beefed up the ship's heat shield to withstand the higher temperatures and pressures. And for today's test, like really getting through hot staging would be a major milestone. There are some risks associated with this test, but of course, the ship and booster are going to be pretty far out over the ocean in the safety zone and far away from people.
Yeah, regardless of what happens, it's going to be super exciting to watch. Now, in addition to the first and second stages of the vehicle, Starship has a third stage that we call Stage 0. This consists of the launch mount, the tower, and the tank farm, all of which you can see there on your screen, as well as the pad infrastructure built around the rocket. Fun fact, it's the Guinness Book of World Records holder for the largest launch tower in the world. What a beautiful drone shot that we have here. Also important part of the system, but less visible right now, especially because of the fog, is our new water-cooled steel flame deflector, and that's certainly a new upgrade for this flight.
Yeah, on Flight 1, the Starship's launch pad was damaged pretty significantly during liftoff as those super heavy Raptor engines fired their full thrust into the foundation for more than 12 seconds. So now we have a new high-pressure, water-cooled steel flame deflector system that we developed and installed between the flights, and there you can see the video of it dispensing 260,000 gallons of water. And that's designed to dissipate those loads from the Raptor engines and support rapid turnaround of the launch pad with minimal refurbishment between flights. part of a rapidly reusable launch system also means the pad infrastructure.
Yeah.
We performed multiple standalone tests and have used this new system for both the Flight 2 booster static fire
15
tests.
minutes, folks.
And we've also reinforced the pad pretty significantly from Flight 1.
Yes. Now, also part of stage 0, we mentioned before, the launch mount. Kind of hard to see there, but it's what the booster is connected to. Oh, here we can see basically the legs of the launch mount. This is what holds Starship and all of its mass. It holds Starship during ignition, right there at the Super Heavy booster. This is what houses all of the equipment needed to fuel the Super Heavy booster and condition it for flight, as well as all of those electrical, communication, and data connections between the ground and Starship. Bottom line is, it's an important part of how we talk to Starship on the ground and understand that it's really ready to fly.
And of course, the awesome camera shot there of those 33 Raptor engines.
Such a great view. We don't have that view for Falcon 9, so I
wish we did.
love that we get it here. Now, as we mentioned earlier, the real game changer with Starship is not only mass to orbit capabilities, but that it's designed to be used over and over and over again with little to no downtime in between. Full and rapid reusability is the key to making routine space travel a reality, and SpaceX has been working on this since its inception.
Yeah, with SpaceX's family of Falcon launch vehicles, which are the first and only orbital class rockets capable of reflight, we started that. And Starship is going to take this even further with a reusable first and second stage. Now, while most rockets are expended after their portion of the mission, SpaceX rockets land back on Earth and are quickly returned to our hangars to prepare to refly again.
Exactly. In fact, 90% of all Falcon 9 boosters that have flown this year have been reused, or as we like to say, flight proven. So while launching and landing rockets may seem routine today, this was not always the case. For those of you that have been following along since our early days, you know that it took us 4 attempts before we successfully launched our first rocket to orbit. Here you see our Falcon 1 Flight 4. 15 years ago in September, that vehicle became the first privately developed liquid-fueled launch vehicle to orbit Earth. If Falcon 1 Flight 4 had not succeeded, it would have meant the end of SpaceX.
And our first successful landings didn't come easily. We had to miss the target a few times before we ultimately stuck the landing. But each of these landing attempts, how to not land an orbital rocket, were teaching us what we needed to know in a flight-like environment to get that full picture of how all the systems interacted together.
Oh man, yeah, this is me trying to not get goosebumps watching this first drone ship landing. I hosted that webcast, and it was so exciting to see that iterative development approach that we took finally paid off after so many attempts of failing.
That's crazy that was only 8 years ago.
Now that failure is
Wow.
expected to help improve future designs of our vehicles and systems. So fast forward
Successful
to
landings
present day, we've
since.
landed F9 boosters over 245 times since our first reflight of an orbital class booster 6 years ago.
Yeah, and it really comes down to our design philosophy. If you're not failing in some way, then there's room to learn and push the design to improve. And failure doesn't just mean blowing up a rocket. It might be not being as efficient as we want to be or producing slower than we want to. So that approach has been the basis of how we've made all of our major innovative advancements.
All right, now Falcon 9 has certainly come a long way, and Starship will too. But as a reminder, today is a test. We really hope to get to stage separation, but any data received will help us improve. It's the second of many future flight tests of Starship before it becomes fully operational.
And these flight tests teach us about the limits of our design. They help us improve our understanding of the vehicle, and ultimately will help us to make Starship more reliable and rapidly reusable. So again, whatever the outcome and however far we get today, we can promise excitement. So why are we doing
This is
all of this?
crazy. Do they
Why
only
do we
have
need a rocket this
83,000
big,
people
and why does
watching?
it need to be
That's so
reusable so
small.
quickly? And that answer goes back to SpaceX's mission,
Down the
which is to
lower right
make
corner,
life
looks like they had
multiplanetary.
some sort of other gantry there
We aren't
for
just
windows
building a
or
new
for
spacecraft.
cameras.
We're changing what it means to go to space. By building the most powerful rocket ever flown and a ship designed to carry people, cargo, habitat, satellites, and more, we're unlocking a future where our dreams of exploration will no longer exceed our grasp. And this mission continues with flights like today's integrated test.
And these are flights where we're going to fail fast, but learn even faster, where each time we're going to try something new while flying something that we've improved. And ultimately, that's going to build up a fleet to fly early and often as Starship rapidly evolves to become more
10 minutes,
capable
baby.
and more reliable.
The first stop is our nearest neighbor, with a surface that hasn't seen visitors in more than 50 years. Under Artemis with NASA, Starship will return people back to the moon. After those first expeditions, we'll be ready to fly more people along with everything that it takes to build a moon base. Think about that. Hardware that will enable us to live on another world is sitting on a launch pad on Earth right now.
Oh my God.
And the moon is just the proving ground. When the time comes to make that leap to Mars, everything gets ratcheted up by orders of magnitude.
The logistics of supporting an entire city on Mars are daunting, requiring millions of pounds of cargo flown from Earth spread out over thousands of launches. We just broke our own record for the number of launches in a single year, and we're going to break it again next year.
Now, in the years to come, Starship is going to dwarf those figures as we bring it online and truly make life multiplanetary. But for now, anyway, as the clock counts down to today's flight test, why don't we get another status update from John?
We're just over 9 minutes from liftoff as the countdown clock clicks to 0. Good news is teams aren't working any significant issues on the launch vehicle right now. Propellant loading is continuing on both the Super Heavy and the ship stages. Most recently, we began loading LOX and methane fuel into the header tanks on the Starship. And on the graphic on the left side of the screen, you can see up in the nose of the second stage, what we call Starship, are those 2 header tanks for fuel and oxygen. Now that loading started at T-minus 24 minutes and will continue until approximately T-minus 5.5 minutes. Now Starship's second stage main fuel and LOX tanks are loaded for flight. And the second stage
awesome
pump that we're
graphic, by the
loading
way.
on board
I love
is
it.
going through the quick disconnect that comes out on the arm that's located at the base of the stage from the tower. Now on the Super Heavy booster, propellant loading will continue until T-minus 3 minutes. We've also configured the pad for liftoff. A little earlier in the count, the hold downs, the booster hold downs were commanded to unlatch. That means once the rocket has sufficient thrust to overcome its weight, it'll lift off the pad. There's no need to command the hold downs to release the rocket. As we mentioned earlier also, the ignition sequence has been slightly modified from the last flight for a more efficient liftoff. As a reminder, we ignite the engines a few seconds before T0. We don't lift off exactly at T0. We lift off a few seconds later, a couple seconds. Finally, the SpaceX team continues to check in with the Coast Guard to ensure there are no boats in the safety perimeter before proceeding with launch out over the Gulf of Mexico. Now, currently, we're coming up T-minus 7 minutes, 10 seconds to the test flight of Starship. Propellant loading is continuing on both stages of Starship.
I guess that's
We're
a
waiting
relief
now
valve there.
for the
That was
completion
cool.
of loading
header
of the
tanks,
header
yeah,
tanks
relief.
in the next few minutes. The first stage is also beginning pressurization for flight while we are continuing to load propellant into it. And again, booster propellant load will finish at approximately T-minus 3 minutes. At that stage, both first and second stages are fully loaded, and we'll have the 10 million pounds of liquid propellant on board the 2 stages of Starship.
Hey, Xander, how's the excitement
Now, in the
locally?
next few minutes, the guidance system will perform its final alignment. We'll get the automated flight termination system that'll arm, and the final TVC checkout will be performed. We may get a view looking up at the engines as we gimbal the 13 middle engines to check them out just before liftoff at about T-minus 90 seconds. If we need to hold, it would come at T-minus 40 seconds. That's the point in the countdown where we can pause to wait for final checkouts or pressurization to complete. Or, as we're hearing right now, we're still working a few boats in the area that are headed south.
Woo!
And a lot of cheering here in Hoffa.
Yes.
The boats are heading south, but we are still planning to hold at T-minus 40 seconds if necessary.
5 minutes.
Just amazing views of today's launch. There's nothing quite right like a launch at basically sunrise. Sunrise, I think, was just about 10 or 15 minutes ago out at Starbase.
Yeah, these views are just incredible. Couldn't ask for a more beautiful day to attempt a test flight here. Again, these
Also,
are
this
live
fog
views
sticking
of
around is a good sign.
Starship
It means there's
as
almost
it
no
awaits
wind.
its second integrated flight test. Our primary objective today is to get through stage separation. We really want to test out our attempt to perform hot staging, where we are going to ignite the engines on the second stage while some of the engines on the first stage are still lit. So essentially both stages will be making fire at the same time, and that will push the booster away from the ship. It'll separate the two stages. So that's the primary goal for today. We really hope to be able to test that out. But at the end of the day, all and any data that we can collect is going to be incredibly helpful and help inform future improvements and iterations of the vehicle.
Yeah, Kate, there are other objectives for today too, assuming we get
you're
farther
saying might be
than
related
stage
to the data
separation.
system, so
There's
they're
goals
probably
to
getting
test
that
out how reentry goes on the ship portion. If the booster survives stage separation, then it's going to try a boost back burn and hopefully a soft landing as a sort of dress rehearsal for what it would look like on land. So everything coming up to that big design change, though, of hot staging today.
Yeah, exactly. Like you were saying, that booster, it will be attempting a water landing in the Gulf of Mexico. We don't intend to recover any of the hardware for either the ship or the booster today. But that booster, yeah, we want to try and demonstrate controlled ascent through most engine cutoff. We want to try to demonstrate that hot staging separation and boost backflip, trying to basically demonstrate controlled burn and entry and that soft water landing. Like you said, it will help inform when we attempt a land landing, but we start in the water first.
Exactly.
Just like we did with the Falcon 9.
Yeah, exactly. And, just getting to hot staging, though, is going to be farther than we got on Flight 1.
Yes.
Flight 1, that was about as far as we got. We didn't have hot staging on that vehicle. So that's the first and foremost objective today. Get that far, hopefully.
Fingers crossed.
Now, one thing that's a little cool about Starship, and it's different from Falcon 9, is we can actually hold a little bit longer if we needed to than we can on Falcon 9 missions. Once we get to T-minus 40 seconds, and if we did have a hold, depending on the reason for the hold, we can hold for up to 30 minutes. And today, actually, our entire launch window is about 20 minutes, so the whole duration would cover most of our launch window.
Yeah.
And that's different from Falcon.
Yeah, absolutely. With Falcon, we have to go exactly at T0. That 40-second hold is super helpful. If we need to, for example, we need more time to pressurize the COPVs for flight levels. Perhaps fuel.
If the engineers just need to look at some of the data, see how engines are performing, or the avionics.
Exactly. Those checkouts, being able to have the opportunity to top off the fuel or LOX if it's not fully loaded. And, we might want to just take a few more minutes for that. So that T-minus 40-second hold can be really helpful. But we don't have that option on Falcon. So it's a little bit different here.
We're just
Herbert,
inside
just FYI, I
T-minus
can't
2 minutes
see
and
us.
counting.
I can only see the
good
video.
news right now we're hearing, it doesn't look like we're going to need to hold a T-minus 40 second as the boats are clearing out of the way. Next event coming up, TVC wiggles as we move the center engines on the first stage.
It's incredible that they released the hold down clamps already.
can see maybe just a little bit there. 90 seconds
for no
wiggles
wind,
are
no
underway
breeze.
as we're checking out the first stage.
Well, it's so heavy
Xander,
right
that
now,
view
it's
is
not going
awesome.
anywhere.
That is awesome. Yeah.
The
You
only
see
clamps
1
is
minute
hard to be a
complete.
hold down clamp.
Next major event we're going to hear, hopefully, is the flight director go for launch at T-minus 30 seconds. As we're coming up on T-minus 1 minute, when we get to
There's a
T-minus
good
40
chance that
seconds, we'll
we'll
just
see
listen
Xander's
in.
reaction
Last time, as you
before we
recall, we
actually
did
see it
hold
go
at
off
40
here.
seconds.
There's usually
It
a
took a few
delay
seconds
in
for
the
the clock
telecast.
to recover, so we're going to
So
watch that.
Xander will probably
And as
tell
we
us
press the
before we are able to
T0,
actually see
we're
it,
going to
how
watch
it's
and
going.
listen the second test flight of Starship.
My experience is it's about 30 seconds behind the actual launch time.
All right. So we've got our expected hold at 40. Hopefully that'll be very quick.
Woo!
Is it moving?
It's gonna happen.
Very good.
Okay, it's going good.
All right. I'm going to leave my mic on. Sorry, folks, if I scream.
T-minus 30 seconds. Back to
Oh, wait.
recycle.
They recycled to 40.
Recycled 41, okay. Now, they only have 20 minutes to play with here. On Friday,
Right,
yesterday, they
right.
had, a couple hours, I think, in the window, 2 hours, but we only got
But I think
20
they
minutes.
just said that the prop load and everything only allows them about 30 minutes anyway, so they don't really have that much time.
Okay.
No word
Why
on what
him?
happened, eh?
Back at
Can they get that
Hawthorne, we're
40 seconds?
T-minus 40 seconds in
Could move for
holding.
a second, okay.
We had a rapid
that's-
recycle. We've not heard anything over the countdown net as the team works both first and second stages. We're going to monitor the nets here for a minute.
Basically, the referee said, put 1 second back on the clock. 1 second back on the clock.
Yeah. Xander Skycam is awesome.
Yeah.
That's great.
I have a feeling it's because of boats in the area.
Got a little bit of an update. We're continuing to hold at T-minus 40 seconds. This is the normal hold point for Starship, as we talked earlier. Sounds like we're working just late pressurization on, I believe, the second stage. Team is working it. All the other systems are on hold right now at 40 seconds. We can hold here for about 15 minutes or so before we would run out of window for this morning.
Yeah.
So right now they're working on filling pressure vessels,
Only 150
and ideally we'll be able to
Tim
solve
Dodd
this
must be
and
taking
come
them
back
all
and
away.
release the clock at T-minus 40 seconds.
So
We're
as
gonna
an
continue to
FYI,
listen
as
and
this is
monitor for
experimental,
another few
all this
minutes.
propellant load is like a dance, and it all has to be done perfectly. So obviously they're still working on timing.
I see.
Yeah, it's always a trick because you've got the boil
And
off.
it's
so
worth
you're trying to
mentioning
put it in there
here
and you don't know
that
what the conditions
don't
are
go
gonna be. That's
away.
why we're
We are
consistently
holding at
boiling
T-minus
off.
40 seconds, but once the teams have resolved and see the data that they want to see, the clock can restart straight away, and it'll start ticking down from T-minus 40 again, all towards liftoff.
Yeah, exactly. Now, while we do have the ability to hold for up to 30 minutes, we only have a 20-minute launch window, so don't go away, don't change the channel. And just like Shiva said, we can restart that clock, and there it is.
And there it goes.
The clock is going?
Clock is rolling.
Okay, there it goes.
T-minus 30 seconds.
Oh, come on, baby. Yes. This is absolute insanity how big this thing is. If you haven't been to Starbase, go to Starbase because it is worth seeing this thing. It is massive.
16, 15, 14, 13.
Come on, baby. Come on.
10, 9,
Oh,
8,
yeah. Come on.
5,
Get
4,
off the tower.
3,
Get off the tower.
2,
The system?
Woo! Come on. Oh, great.
Whoa.
Come on, baby. Get off the tower.
Okay.
Yes.
No power, no power slide. Looks good.
Yes. Get off.
Wow.
No engine
I
outs.
don't that thing. That is ridiculous. Oh
Looks
my
beautiful.
God. And what a view today, dude.
No sputters. Everything looks great.
Yeah, we don't have the engines all look good. That looks like all of them.
Beautiful.
Oh my goodness. Wind's max Q about 1,100
It's about
kilometers an
a
hour.
little after a
around
minute,
there.
something like that, around 70 to 80 seconds.
Starship, 33 Raptor engines
Acquisition
powering the
booster
first
range
stage.
power and telemetry nominal.
We've heard
Nominal.
That
Great
acceleration
call out.
looks so much better.
We're heading downrange.
Holy
towards North
crap.
Mexico.
Look at the color. What a beautiful color of metal.
That is beautiful. It's so much better than the first test. That looks absolutely perfect. Come on. Hot squeezing. Hot squeezing. Wow. Oh, Xander.
That call
Excellent
out tells
view.
us Starship is through the period of greatest stress on the way to space.
Come on.
Now the next major event is hot staging in just over 90
what a
seconds from
view.
now. To get ready, the booster will shut down all but 3 of the Raptor engines. Clamps holding the 2 stages together will release, and the Starship's second stage will ignite its engines. Starship will then separate from the Super Heavy booster and head to space. And at the same time, the 3 engines that are still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first
Come
stage
on.
on path for a splashdown in the Gulf of Mexico.
You get out of there in a hurry. That's why it's hard to track.
Oh yeah. What is it? Is it 2:30, 2:20? About when is the hot stage?
Yeah, it's coming up soon, very soon.
Yeah. Yeah.
It's just past 2
Holy
minutes.
crap. Look at how, oh my gosh, that's beautiful. Wow. Oh, keep it on this view. We need to see. We need to see the
Engine
hot
power
staging.
continues to look nominal on
Now,
33
we will see
Raptor
the engines
engines.
cut, but a couple will
We're
stay
about
on
to
for hot
shut down
staging.
the first stage
Yeah.
and perform staging. Let's watch and listen.
Oh, here we go. Here we go. Come on. Oh, man. When is it actually?
And acquisition of signal Houston and New Orleans.
Nice. Oh, it's getting out of there.
Yeah, that methane. Oh, see,
Booster
there's the
engine
three
cut
engines.
We got
Keep
three.
Hot staging.
Come on, hot staging. Come on.
Shut down right when they're supposed to.
Oh.
There's look
Stage
at that.
separation.
Yes.
Oh, that perfectly.
Yes.
Perfectly. Yeah. Yes.
That's insane.
Oh my God. Look at
Oh my
that.
God, it worked. That is absolutely crazy.
The first ever successful hot stage for SpaceX's Starship.
Now it's showing those other engines. I think that's not really, they're not really on.
Incredible views of
Yeah.
our
It's
Super
telemetry.
Heavy booster.
Oh, it
And
blew up.
As you can see, the Super
Oh,
Heavy
no.
booster has just experienced a rapid, unscheduled
That was the booster,
disassembly.
though.
However,
That was the booster.
our ship is still underway.
Okay, so
with
it should
all
take some
six.
damage.
Power and telemetry nominal.
Yep.
And we just heard there, ship avionics, power and telemetry nominal. All 6 engines are lit, as you can see
Holy
from the
crap.
GUI
Is
there
this thing gonna
at the
get to
bottom
orbit?
right-hand side of your screen.
They're going to hear a big sonic boom coming in pretty quick.
Now, we did know that the that hot staging was going to be incredibly dynamic. We knew that there was a chance that the booster would not survive, but we're going to take that data and figure out how we can
Incredible.
make the booster better for the next hot stage.
We actually have Starship
yeah, that hot
going to the
staging put a
stars.
lot of load
Finally.
on the top of the
There's
booster.
pieces coming down.
And of course, it flipped around there. A lot of dynamic stuff happening.
That's why they don't have any
But
boats
ship
in the
is still
area.
going strong.
And it's doing
Yeah,
great.
yeah.
Right now,
Watch out for the sharks.
ship, the
Hey,
second
sharks,
stage
dive down deep
is
now.
on its way. Like we said, you can see all 6 of its engines are ignited. The next major milestone for the ship will be the shutdown of those engines, or SECO, second engine cutoff, which if you follow our Falcon 9 launches, familiar terminology there. So far, today has been incredibly successful, even with the RUD of the Super Heavy booster.
I love
this
the
is
LOX and
amazing.
CH4 graphic there. That's so
Primary
helpful.
objective of the booster today to get to hot staging, to get ship on its way to orbit. It did that admirably.
Yeah, we definitely
There's something
asked.
was showing just
Trajectory
before it
nominal.
rutted.
All
That
right,
the
great
telemetry
news
was
there.
showing a
That
bunch of engines lit up
trajectory
there.
for ship
Acquisition
is
of
nominal.
There's some leaks on the bottom.
Once again, Starship's second stage. It's firing those engines, and as you just heard, everything's looking good. Now, for the
Brett,
ship,
I love that.
we
Go boom.
wanted it to survive hot staging, which, as you can see there by that little dot on your screen, it did. We also want to basically demonstrate that the successful startup of those engines, demonstrating controlled ascent, which is what it's doing right now, and eventually orbital insertion. We are hoping to basically send this around the Earth, and if it makes it this far, splash down in the Pacific Ocean, a couple hundred miles north of Hawaii.
So do they not have any cameras on this
Now,
thing?
if we
They
get
said
that
they were
far,
testing Starlink.
like all of that sounds great. Secondary objectives
Yeah.
for ship, again,
I was
continuing
expecting
to gather engine data and about its health, performance.
Nominal ship chamber pressures.
Great news there.
they
That
didn't
tells
give
us
us
that
that
the
feed.
chamber pressures inside of the Starship, again, that's that small dot on your screen, the basically the propellant pressures in the ship are looking good.
Where are they going,
Yeah, the
Scott?
bottom right corner of your screen,
There-
you can see
I believe looking at what
essentially
they
a
showed
user
before,
interface
they
showing
may
us
have
which
gone a little bit
engines
over
are
the
lit.
Yucatan
So
Peninsula,
the
and they're
3
trying to
center
thread the needle,
sea level
a
Raptor
little bit
engines on
south
ship
of
are
Cuba,
gimbaling engines.
and
The
eventually
3
they're gonna
outer
land
engines
just
in the
off the
triangle,
coast
the
of
larger
Hawaii.
ones are Raptor vacuum
So
engines. All of
They
them
are
continuing to
not gonna do an
fire
orbital burn. They're
nominally,
gonna
so they're
be
at the
almost quick
pressures
enough
that
to
we
be up in
expect
there,
to
but they
try
want
to
it to be
get
able to naturally degrade
into our target
in
trajectory
case
today.
something happens
Yeah.
and they cannot
And we're not
deorbit.
targeting
So
orbit
it's more
today.
for
We're
safety reasons
targeting
in case
almost
something
orbit
fails,
today.
that you
That's
don't want
very
that just
intentional
sort
as part of
up
the
in
mission
orbit,
design. The goal
uncontrolled.
is to get to a
So
thrust
also,
profile similar to what we would need for orbit.
they need
but
to get
also
to 25,
get
just
the
shy of
energy
25,000
levels
kilometers an
that
hour,
the
and they've got
ship
very
would need
little
to dissipate
LOX
for
and
re-entry.
CH4 left.
And so,
So-
we're actually going
But now is
Interesting.
when the pedal is really
somewhat
going to be
little
to the metal.
trajectory today.
Oh, wow. What is
But
that?
that trajectory will get us to the energy
That's probably
levels
the
that
jellyfish.
we need at re-entry.
Uh,
where we can
yeah.
really stress that heat shield and get
Getting-
valuable data on re-entry.
Wow.
See, if you notice,
And the calls
it's
that
moving up
we
pretty
are
quick
still
right
on
now.
a nominal trajectory.
Yeah, I mean, they're
Because
really
your thrust to weight
dialing it
ratio
down
is
in
just
terms of
taking
the
off.
hitting our target orbit.
Because you don't have that much propellant right now,
if
it can just
the
accelerate.
booster
Like
had
look at that, look at
survived,
that. We need to
we
get
would
up to
be,
Yeah, it's
25.
going crazy.
around
The last
time
couple
where it would
minutes
be,
are nuts
getting
time.
ready to
So they're gonna
Yes.
they're gonna leave some in the
its,
header tank though for
re-entry,
an
but it
attempted
unfortunately did not survive.
re-entry.
Yes, yes.
Okay.
That being
Yes.
said, that's okay. It survived several
Turn one, guys.
seconds after hot staging, so we're
they
going
are
to take
almost
that
out of fuel.
data and improve
Propellant
the hot
using.
staging
They're in
sequence
space,
and
they're above the
probably
von Karman line
improve the
at this
hardware
point.
itself for
So
the
very
next
somewhere
close.
around 24,000 probably. So they're a little shy of orbital.
Yep, they're just about there. I
Yeah.
think they actually hit orbital
Yeah,
velocity.
that's
but
it. That's
just
it. 24,000. Yep.
Yeah, so they are almost orbital velocity. It's just that it's an elliptical orbit, and they would
Right.
need to do a second burn in order to make sure. So it's
Right.
now going to naturally decay.
I believe what happened, they'll hit a perigee and then they'll hit an apogee and then they'll hit a perigee when they come around
Perigee.
over Hawaii,
Yep.
and that will naturally bring them back into the atmosphere.
Yeah.
So it's not, it can't possibly, even if the ship was completely out of control, it would. It's
They're
really a shame we
standing
don't have
by for,
views though.
Call out here. Coming up on
And
the
it's
projected time that
not even
ship would
200,000
shut down
viewers.
its engines.
Yeah. Now it got some. So you can see there was just enough left in the propellant
As you
tank
can
to
tell
get
by
to.
the excitement from the crowd here
get to
at
orbit.
Mission Control Center
Yep.
in Hawthorne. There's a great view of our Star Command Center. That's our control center
Oh,
at
Kimball's there.
Starbase,
That's
Texas.
cool.
The crowd here, Mission Control Center behind us in Hawthorne. Everyone is super exciting. What a successful day this has been so far.
And now we can talk for a while. Oh, here we go. It would be lovely if we got acquisition of signal. It'd be nice to see a view from orbit. I mean, come
Yes, see, especially the idea that it's going to be communicating with Starlink directly in orbit.
on. Right. And I think I mentioned that. I think I mentioned that in the comments, but we're on Starlink, so we're actually using
And I mean,
SpaceX
up to this
technology
point,
to come to you.
major
Yeah.
successful milestones
But that's gonna
through
be
hot
weird
staging,
for it
which was the big
because-
objective today.
I mean, talk about mobility. That's a little bit different than the normal idea that you're mobile on the ground, and it's moving
Right.
at an extreme rate, going from one
So
cell to another.
we are
So
going
they
to
must
head
have
into the
had to
coast
do something
phase.
to be able to accomplish
Planned
that in
for the
space.
next about hour and 5 minutes. We'll be returning around the T+1 hour and 15-minute mark. And
Okay.
that's while we're waiting for Starship to continue on to its next step for reentry. We're not totally sure what video we're going to get.
Oh,
and that video
okay.
comes normally by overflying ground stations.
That's a lucky
but we
kid.
don't have a ton along our flight path. So fingers crossed that we will get some via Starlink on this mission since we're testing that out.
So, yeah, so I guess their flight path is going over the southern part of Africa, and
And
then
also give us a moment. We are hearing some chatter on the net, so we're going to try to parse that for you.
And then I think it goes over the Indonesia.
right. Chatter on the net. Was that fun, Xander? Was that cool?
That was so cool. Can you guys hear me okay?
Yes.
Yeah, how loud was it?
It wasn't like, difficult to, I didn't have to cover my ears. But you feel it, you feel the rumble. What was interesting is just now we heard the booster separation,
Wow.
echo.
RUD.
So,
Oh,
and-
okay, so it took that
yeah,
long.
yeah.
Yeah.
yes, right. It took
It's
really,
about
really
5
like
seconds a
maybe
mile.
5 minutes.
Wow.
Gotcha.
That's
Okay.
crazy.
Okay, so it was about 5 minutes
Did
after
you see
it
the
RUD'd.
Did you see the RUD? Whoop.
Oh, that wasn't me. I thought that was me.
John Innsbrucker back here in Hawthorne at our webcast desk. We have lost the data from the second stage. We heard a
Oh.
call out that we were internal guidance, which means we were getting near the end of the approximately 6-minute burn of Starship. But we haven't gotten any more data since then. So we think we may have lost the second stage. So we would not be into coast phase. We wouldn't be able to come back in an hour or so and possibly
Aw.
get ready for reentry. However, what we do know right now is we had an on-time launch at 7 o'clock. We got through the boats. First stage looked beautiful with 33 Raptor engines firing. We got the hot staging, you know, the thing that we really wanted to see and impressed. We saw the separation, we saw the flip maneuver, we saw the light up of the 6 Raptor engines on Starship, and it headed away. Everything really looked good. But what we do believe right now is that the automated flight termination system on second stage appears to have triggered very late in the burn as we were headed downrange out over the Gulf of Mexico. But the real topping on the cake today, that successful liftoff, Kate, Shiva, the hot staging is just beautiful. Exactly what we were looking for.
Yeah, ultimately, honestly, such an incredibly successful day. Even though we did have a RUD, or a rapid unscheduled disassembly, of both the Super Heavy booster and the ship, that's great. We got so much data, and that will all help us to improve for our next flight.
Of course, and that's why we flight test, and you can bet that there's going to be more to come. So we really do want to thank you all for joining us. Of course, we want to thank the people of Cameron County. We want to thank all the federal agencies that have supported us for our test. And of course, a huge congratulations to the entire SpaceX team on getting through this flight test today. And I think with that, we're going to sign off from here in Hawthorne.
Thanks so much for tuning in, and we'll see you next time.
Okay, did I understand John correctly that he said the flight termination system on the second stage was triggered?
Yeah, but it sounds like it was just at terminal guidance, which is crazy. Usually they FTS safe it at that point, but I don't know.
Yeah,
so that would be
maybe it was just it might have just been a failure in the FTS that brought it down, because you would think at that point the engine shut down, everything was going perfectly, there was no danger to anything.
It would have just, gone. Yeah, maybe they
that's
actually
like the worst time to do FTS, because now you get a bunch of orbital debris.
I know.
And I think,
oh gosh, that's right. That stuff's just going to float around forever now.
Yeah, some of the stuff's going to come down because it's pushed down, but some of it's going to go to a slightly higher orbit. That is concerning. Now, so it was not the FTS on the first stage. All I'm imagining is that that heat shield may have done enough to sort of protect it, but maybe it was still just so hot that somehow it just caused the upper part to lose its integrity, and then it just decided to go.
Yeah,
it's really strange that it waited that long before it decided to RUD. I thought it would have been cooling down, but it probably had a hard time cooling down if you think about it, because they were high enough in the atmosphere. It's not like it was getting a cooling breeze.
No, it would have been only radiative cooling, and they may have not taken that. Well, I shouldn't say that. I'm sure they did, but it just may have taken a while to heat up. It's the CH4 on top there, right? It's the methane. Yeah. So it just may have taken a while to heat it up, and it just may have overpressured in the sense that the heat from the top boiled it, because the methane is very cold.
Yeah.
So they just might have to insulate it.
Yeah, if one of those welds kind of fails, that's all it takes, and you get that rupture, and then it just becomes
an overpressure,
a poor man's flight termination system.
Still amazing. It's really a shame, though, that the second stage flight term, of all things, why the flight termination system? I really hope that we got some video from it. I know they didn't show it live, but I'm hoping they got some telemetry that at least showed it from that point of view, because that was a shame.
They must have a lot of internal telemetry. Yeah, because they had cameras all over the place. We're going to see later on today them compositing everything. That's because they had the camera right underneath the booster or launch. I want to see that one and whether that survived.
That one took one for the team, I have a feeling.
So we will see the Starship blowing up as well, you think? That you were saying too? Not just the booster.
Unlikely.
No,
I think we actually saw it right at the very end. There's no way to rewind it, I'm assuming, but right at the very end, when it was way up there, they just had a shot of the sky and you couldn't really see anything. And all of a sudden it just was a poof. There was like the jellyfish, but then there was a big kind of like this. And I that would be my guess in retrospect. At the time, I thought it was just the engine shutting down, but my guess would be that that's the moment when it went poof. So yeah, it is unfortunate, Scott. You're right, because obviously an explosion happens in 3 dimensions. And so the lower stuff is going to reduce the speed and drive it back into the atmosphere, but there's going to be pieces that went up and are going to be
they're either going to around now, or they're going to go very high apogee before they come down.
Yeah. So that's a shame. Wow.
So where will all the debris fall? It's just the ocean,
Hawaii.
And then You said
over the
some might
place.
be in space. That's how
Yeah,
far
some
they
of it
went.
might come down in a couple of weeks. Who
Yeah.
knows? Who knows what kind of trajectory some of that might be.
Right.
So
I-
anyway,
it was
the thing is-
suborbital, so most of it's coming down quick. Like within the
Okay.
next hour or two, it'll come down.
yeah,
but
hopefully
there will
there's
be
still enough
pieces of it
drag.
that went up and will have gained extra velocity,
Why-
which will make it orbital. So yeah,
Why did the Starship blow up? I mean, it's already way out there. There's
That's
already
a big question.
yeah. I think it was an error in the FTS system because usually you hear the call out with Falcon where they do FTS safed at before it gets to orbital velocity. So maybe they tried to shut it down and it triggered it instead, or because usually you want to turn that off so that you don't have exactly what just happened.
I wonder how many fail safes they have on those things.
Right.
Remember, you've got explosives, which you've
Right.
got to be handled very carefully, and you think about everything it's going through. There could have been any sort of things that trigger it. So they must have something to make sure it shouldn't accidentally do that.
Right.
And but at the same time, usually they have cordite or something like that. They run something along the booster, and if some line is broken, then that will just trigger it. So
Right.
it can be pretty skittish, and maybe that's what it was. It's just some small thing failed, indicating that something wasn't going quite right, and it's decided, okay, let's terminate. But I would.
But
think
that's
if you
usually why
would-
they safe that. Yeah.
Yeah, but usually you're trying to safe it to make sure it's not going to cause destruction to any sort of property that's right there. But
Right.
I would think almost right after you do staging, you would want to just turn that off, because at that point it's not really a threat to anything unless it just starts to veer, crazily off in some direction. So somewhere in there, they should have been able to say, shut that thing down.
Yeah,
That's not
I have
worried about it.
just imagine if you were the guy who was supposed to click the button that's like safe it, terminate it, and the guy hit the wrong button. He's like, damn it, no.
No, could be.
Could have just been human error. You never know.
Yeah. Yeah, but you think you'd have enough safeguards on that.
Right. But you also have to be able to trigger it immediately. So there probably is a guy that's just sitting there. Now, I can't imagine that that would have been like that. But, there probably is a guy with his hand just like over the button, just waiting, because in case they have to fire it, they have to fire it. So, thank you, Herbert.
Yep. So Xander, you're there. Tell us what you're hearing on the ground. Who's around? Oh, we just lost them.
We just lost him. Just in time for that to happen.
Rapid RUD first, Xander.
As long as it wasn't a piece of booster debris. The booster, I have a feeling if we go back and look at the frames and acceleration data like you did last time, Scott, that we're going to see a much better acceleration profile through the regime.
Well, I've got it here, so I can move around. Where should I go?
Nice. All the way
Let's
to the
start
end.
right at the beginning.
Well, okay, but skip to the end first.
Not at the
I
very
wanna see
beginning, but
right at the point. So all the way at the end, like 6
around
plus
2
minutes.
2 minutes. Oh, okay.
Yeah. Because I want to see, because I think right about the time when before the acquisition of signal thing, right at the time when you saw it, there was just a little poof right at the end. So it'd be before
A
this.
little bit before there.
Wait, right here?
About 6
Nope,
minutes.
Go back just a little bit. Let's go back.
Yeah, go to like
Sorry,
6
yeah.
minutes.
I don't know
Like
where
on the
6 minutes
Starship, the
is.
T+6. That's what I mean.
Oh.
Sorry.
T-
Yeah, sorry. I guess I was looking at the little timer there. Yeah, right there.
There's
So
good.
just leave it there.
There's good.
Okay.
Okay, and then
So we had the
we can go back
jelly.
to the beginning in just a second, but I swear I thought right at the very end, it was like doing that jellyfish thing, and then all of a sudden it just went. There's a little
Okay, yeah.
pop.
So we're still going here, and we're seeing it's accelerating rapidly, just
Right.
because the mass is going down. It's exactly what you're seeing is the rocket equation.
Yeah.
And how it
Yeah.
works, and that once you get towards the end, you accelerate really fast. So you were bemoaning the fact that it's not
There.
even close to orbital
There.
velocity.
Yeah, so
Now
now we're
that's
getting
where
to the
starting to get
jellyfish.
jellyfish.
It's-
I'm wondering if one of the engines is starting to have an issue there,
Right. Maybe.
because that is kind of a strange time for the jellyfish.
It's very high.
And
I
it's
wonder if
not
it was
symmetric.
leaking or something. But just watch when
Something
we
is-
get up to about 24,000 kilometers per hour. That's when, just at the time when the engines were supposed to shut
Yep.
down.
Now there's no engine outs. The telemetry seems to be showing good acceleration right there.
Right.
But yeah, that could be that something's starting to fail.
Yeah. So somewhere in the
Boom.
Right there.
There, right
you're
there.
thinking, but still,
But still, it's going.
still
So I
seems to be
wonder if there
going.
was an explosion of one of the engines, though. Even
yeah,
though it doesn't
and the
show it.
telemetry is not showing it at that point.
Right.
You're up so high at
right,
that point, there's
right.
nothing in the atmosphere that would do that. So something,
Yeah.
now we've
Hold on.
lost.
I think there's just, I swear I thought there was a poof right at the end. Okay. Never mind.
Okay,
There
now
it
the
is.
engines
That's
are
it.
out.
Right there. No, did you see that? That was
Ah,
right.
there we go. There we go. We see
Yeah.
something right there. That's
Yeah,
where it
that
went.
was
So
that
now you
was
see
what I
another
saw.
poof.
And I thought maybe it was the engine shutting down, but that's definitely the flight termination. So yeah, right around 8 minutes is when it happened. And
And
it
then we
looks
didn't
like it
see
was
any change in
after,
altitude.
it looks like it was
and no
after the
change in
engine was
speed.
shut down.
Yeah, right
Mhm.
after.
Crazy. So yeah, if you so let's go back to the beginning because that was fun.
What beginning?
Well, the launch. I mean,
The
yeah.
launch. Yep.
Yeah. Oh well. Definitely. I want to watch the rut again too, because I was kind of confused, and then I was like, oh crap, that was the first stage
Yeah.
just disassembling itself. Hey Xander, how was the excitement in the area? Are you around anybody else? Was there some cheering?
There was, yes. We had about 10 or 15 people here,
That's it?
and yeah. Well, we're in a like private. I'm in a private community. I got an Airbnb here, and
Cool.
Will from his handle is CompuLive. He lives here, so he let me set up right, with the view. Was that a good view? Was it
It was
useful?
awesome. It was awesome. Especially
Yeah.
the trail as it was getting up out of there. Yeah.
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 Until it got too small, and my lens is not that powerful.
Right. Yeah. It was impressive that they were able to follow it all the way till the second stage shut down. That's just crazy.
Yeah, so we heard a little boom later, but it was very small. Like I said, it came. So I don't know if that was just the separation, and that's what we heard. But I didn't hear a large explosion.
Yeah,
Right.
probably at that point because it was so far down range, so it would have sounded like thunder, really distant thunder.
Right.
Good point.
They didn't really have
And
a
then-
max Q call out here, interestingly enough, at least not on the screen. But all the engines, like last time, it got off the pad so slowly, and you
Mhm.
could see multiple engines out as it was going out of there. But this
Right.
time, oh, that's pretty. Let's hope
Yeah,
for
you
not
didn't have the
another.
power
What was
slide,
it?
but it did pitch pretty early coming off the
Yeah.
tower. And
Wow,
again,
that's
the
beautiful.
methane burns so cleanly, you don't quite get that long trail that you do with kerosene and with solid
Right.
rocket boosters, which are usually pretty dirty. So at this point, you're not seeing anything.
So we're waiting for
so
the
that means they're
separation,
actually-
right?
Yeah.
Yes, I think it was just around 2.5 minutes. It was later than I thought it was going to be. But you
Yeah,
see it
so-
like it shuts down and there's only 3 engines operating for a few
Right.
seconds before. Yeah.
So
I actually want to watch the speed as it does that and see how much it slows down. Like if you see the acceleration like really drop right before it should, because it's only got 3 engines left, but
Right. So that's the thing. They had to get the timing of that just right. And it
Right.
appears that they did get that.
and the clamps release and all that stuff that has to happen. It's
Clamp
crazy that
release
the
and-
clamps actually worked. There's only 3, right? There's only 3 clamps holding it down.
Yes. There's
That's
just 3.
crazy.
That's the minimum
And the
that
whole
you can
thing
get
didn't
by
just
with.
break apart. That's
Yep.
crazy.
Yep. And so when they go down to the 3 and then the other ones have to light up, and the question is, I'm going to look to see whether all 6 light up or whether they just do the center ones. That's something a debate
Yeah.
we were having. Is that
My gosh,
whether
look
they
how
go with
late
all-
that is. We're
Okay,
at
so it says 3,
2:42.
right?
There it is. There it is.
Okay, there we
Three
go.
there. Oh, the 3 outer, and then it looks like so all of them are going, and then finally you get that separation. So all 6 were on.
Yeah. Look at
Because
that
it
thing
was
get out of
holding on
there.
for a while.
That booster got out of there. It was like, goodbye.
Sorry, they powered the booster to get out
Now
of there?
notice all those engine lights are
Yeah,
lighting
yeah,
up there
dude,
for some
all
strange
those
reason,
engines are lit. Yeah.
and I'm
Gotcha.
not sure why. They're not actually on.
Oh,
Right.
are they? I think
Maybe
they
they
are.
are.
I think
Is
it's
that the
doing a
boost
power
back?
back. Yeah, it's doing a boost back right away.
So, but it's a rather asymmetric boost back.
Up, boom. Oh, rewind. That was fun.
So maybe it was something to do with the boost back.
Yeah, it looked like some of the engines started going out, and then all of a sudden you saw a bunch of like flamey. So
Yes,
that's incredible how fast that thing is getting the heck out of Dodge. It wants to be well clear of the Starship. They may not do it that aggressively after they've tested it. They probably just wanted to really get them far apart, so in case it rutted, it wouldn't have an effect on the Starship.
Okay, we're
Yeah,
about
then
to
some
have
of
the
them are
moon.
shutting down. It's a really strange pattern that you're seeing there. I
Yeah.
expect it to be symmetric. And I don't think you would need that many to
Okay.
be able to do the boost back.
That was which way did that come from? I can't tell. Man, I wish we needed a frame by frame because I can't tell if the explosion came from the top or the bottom. I think it actually came from the top, which would make sense because the top would have been heated and overpressured. But like right as it gets to like, you see a bunch of like kind of stuff shooting out sideways, and then I guess it makes sense. You don't really want it. If you're going to do the boost back burn, it's got to be immediate because otherwise, all right.
So maybe something.
No, it came
Boy,
from
it's hard
dead
to say.
center. It looked like it came from dead center. I mean, that's just a guess, but it's really, I know you can't get the frame accurate.
Oh, great.
Oh,
Oh,
Can you rewind
it explodes too quick.
I think if you hit the comma, are you on X or are you on YouTube?
on YouTube.
Oh, okay.
On
If
YouTube, you can
use
hit the comma and the period.
the comma
go
and the
back and
period.
forth.
Yeah, let you go
Yeah.
back one.
Because I want to try to get the frame where it actually starts. It looked like it actually started in the middle when I looked at that for real.
Wait, am I far away?
You're
Where
too
am I?
far. You're too far.
So go back to
What?
a 2 minutes.
You're on the
Yeah,
second.
go
You got to go back. It's
Oh,
about
2 minutes.
about 2 minutes and
Gotcha.
40
down
seconds or
to-
so.
Okay,
somewhere
right
around
there. That's
Yeah. And then when it
That's
gets
it.
to the point, we can stop. But so anyway, what I was thinking was they have to do a continuous boost back burn because they don't have ullage motors. So the same with the booster as with the Starship, it has to continue operating at least one engine to keep the propellant because it doesn't have a header tank, right?
Yeah, there is no header tank.
Yeah. So it has to stay underpowered the whole time. And then it can actually turn it off after a while because once it gets back in the atmosphere, then it will
Okay,
have gravity. that's
what am I
pulling it.
supposed to do here?
Hit the
It's about the-
period. I think period will go
the
one.
period
frame
is forward. So basically, it's the greater than less than, but without the shift key.
Yeah,
So
on your
if you just do
keyboard.
that, it'll go one step at a time.
Yeah.
So right now, if you're paused and if you hit the period right now, it should.
I am
go
doing it. It's
one
nothing
frame.
happening.
Oh,
I'm
really?
doing the period.
Huh. That's very odd.
I mean, I
That's
don't
like
have
a
it
pretty
playing.
looking shot there.
Oh!
Oh, damn. Hit the comma. Now, if you can hit comma and it actually works, then we should be.
Yeah, I'm pressing comma. Nothing's happening. Hold on.
That's a shame.
Yeah.
Wow.
Nothing happening.
Pretty shots.
Are you on a Mac?
This is. I don't think this is YouTube. This is SpaceX.
Oh, okay.
Okay.
Okay. So if you're able to get the YouTube feed on their
Right.
playback, which they may or may
Yeah.
not have.
Let me go get that now.
Yeah, I don't know. Yeah, did they live stream to YouTube this time or did they only do it to X?
Yeah, they did not do it on YouTube. I thought they just did it
Oh,
on
that's
X.
why they had less than 200,000 views.
Yeah, I was
Yes.
wondering about that because I was like, there's no way this is so small. I guess everybody was watching us instead. There you go.
Well, the only way for people to see it on YouTube is that they had to get all the people who were taking the live stream and showing it.
Right.
I think
Yeah.
NASA might have done it.
Right.
NSF, Everyday Astronaut, I think a lot of people were live streaming it.
Yeah, I could try, but I don't know that.
No, I've
let's see
got
if
it.
I can pick something up. Oh, you do? Okay. Did they put it on YouTube?
Well,
or-
somebody else did. So
Oh, okay. There you go. Yeah, I'm really curious to see that exact frame when it started to disassemble because that will tell a lot of the story as to where it started.
Now, if we look in the graphic, it looks like all the booster engines would shut down.
no, these guys don't have it, and this is NASA. What the hell's going on?
Wow.
No,
You could be right, Scott, because maybe the boost back burn was done at that point. It seems a little weird timing that both of them rutted just at the time when when they were finished boosting, basically. So rather interesting.
Yeah.
I wonder if they overzealously got the flight terminate. After last time when it didn't terminate, I wonder if they overdid it on the flight termination systems on both of them. Both of them decided to terminate. Whoop. Okay.
What's happening?
So you said you found something or not? Or
Well, actually, it's funny. I'm going to stream your your video from your channel.
Well,
Okay.
that will be really weird, but okay.
It's gonna be weird. It's gonna be weird. It's gonna be hilarious. Okay, wait. I'm just finding the right spot.
Talk
Okay,
about
watch
meta.
this.
It's just layers.
Yeah, this could be meta. Watch
Put those
this,
all the way
guys.
down.
This is gonna be hilarious. Watch this. Okay.
All right, there we go.
Okay. Where are we? Where am I going?
It's somewhere around. It was around 8 minutes or so. Definitely 8 minutes on the clock. Sorry, I just am looking at the bottom. Yeah, that little thing down there. So go back before that. Right around there.
Oh,
wait,
yeah,
sorry. We're
what-
looking at we're looking at the booster. That's more
So
like
we want to go around
about
2.5
3 minutes and a half. 3.5. Yeah. Okay. Hey, I'm
Six.
damaged, then.
Telemetry nominal.
Yep.
And we just
Oh,
heard there,
we need to
ship
go-
avionics, power and telemetry.
What?
I think we need to go back. Go to around 3 minutes, I think, or just a tad under.
Yeah, I think you got it. There you go. Okay. So now
Okay. So it actually goes. Now it's showing those other engines. I think that's not really. They're not really on.
Incredible views of
Yeah,
our
telemetry.
super heavy booster.
okay,
Keep
now if you
playing
can go
it?
forward frame at a time. Yeah.
Okay.
I don't know if you
frame
can
at
do it with a
time.
live stream or not, but we'll see.
Yeah, it's working.
But yeah, there we go. Okay, so cool. Yeah,
Okay,
just keep
hold on.
going until it decides to
Hold on.
explode.
This is hilarious. Okay.
Get to see ourselves.
Is it working?
Yep.
Oh,
there it
it's
is.
in the
No,
front.
okay,
It was in the
back
front.
one.
You were right, John. That frame right there, we can see where it's happening.
Yeah. Yeah. So it's
Or is
I'm
it's
guessing
kind
it's
of
the
in the
methane tank overheated.
But
So-
it still looks kind of in the middle, so it's not quite in the back, but it did
But no,
start
but
at
the
the
methane
back.
tank. Okay, so if the methane tank, like it doesn't matter, like the methane tank was at the top. So anywhere in the methane tank, if it overpressured, it's going to unzip somewhere. It's just there was
Yeah,
some little rivet or something was weaker than everything else, and so it was bye bye. But definitely the top half of
but
the
it
booster.
looks like it's almost happening where the flash is not an internal, but it's right on the outside. It's either leaking there or,
Right.
you know, don't they have the piping that does the return for the autonomous pressurization system?
Yeah,
I wonder if that was the potential failure.
right.
Now, it's rather interesting the way the cloud goes, the direction. You see, it sort of heads down towards, or it's pointing towards the front of it. It's an interesting
Yeah.
explosion. Until
Yeah,
gets
it was like
everything
a
else.
donut.
Yeah, I mean that there, and go back one more frame. Just okay, so we see nothing there. Do we see anything
Right.
venting there? It's hard to tell.
It looked like the engines were shutting down. It looked like that was the kind of like, you know, you're getting those weird little spurious extras that happen as the engine shuts down.
See that?
But
Yeah, right
There.
there, it just starts
There.
to rip right there. Yeah, that's the first frame of it going.
Yeah.
So-
that's where it was, right there.
yeah, you don't. They couldn't be the flight termination system firing, could it? Who
Could
knows?
be. It could have been. I mean, because it's right on the outside, and that's where it would unzip.
Right.
And
Yeah,
I
'cause
don't
it
think
looked-
I don't think it's a long line along there. Didn't they make it that it was just kind of a small package in one place that they were hoping would make the whole thing unzip? I don't know if they changed that, but originally
Right.
it was just a small area. So
So somebody,
could
we need to look up where the flight termination system on the booster is, because if it happens to be right there, then there's a really good odds that that's what happened. But otherwise,
Yeah.
it may have just overpressured. Wow, you can
But
see all
it's
the
really
parts spewing
it's
out.
interesting
That's
because
cool.
it's falling back to Earth, and so you would expect the streams going in one particular direction. That's why it flew up.
As you can see, the super
How it
heavy
comes out is in an oddball direction. I was expecting it to be more spherical going out from that point, and definitely not so much energy heading in the direction of flight. So there's something odd about that.
So what do you
I
guys
don't
think?
it would
Was
be
this
the engines? If it was
so-
the engines, it would have exploded in the other direction.
okay? So let's pause for a second, right? This is a big historic moment, right?
Oh, yeah.
Because we actually had the first time that Starship, which is the rocket that's going to take us to be multi-planetary, to be able to do the second boost removal, right? That now the boost was successful. That was the
Yes.
big deal. That's what they
Yes.
wanted, right? Why did they
Yes.
want that? What's the value of that?
The stage separation or the
Yes.
um,
Well, what was the purpose of this? I mean, I know that they'll learn regardless of what happened, right? But what was the main test?
The main test was hot staging.
Yeah.
Because
Which is?
the
Yeah.
first time they had a wild way of doing the staging that they wanted to test, and they realized that that's probably not going to
The
work.
catapult.
So- right. So they're going with the hot staging, and they're going to learn a lot about this. Is that did both failures result in something with hot staging? That, you know, it looked like the second stage survived hot staging fine. It looked like, oh, it's on the way. And then we can see that the booster either had difficulty with the hot staging or something else caused that RUD. And then the question is, was there something that happened to the second stage also during hot staging that resulted in it failing a little bit down there? So they have to consider whether hot staging is a good idea moving forward, or what do they have to do differently about the hot staging, because all these things have to happen just right. There's a couple reasons for doing hot staging. One, they talk about that you get more efficiency out of it. Never stop thrusting, so you don't get the gravity losses. You just keep on going up
10%. They
there.
said 10%. It's huge.
10%, which is really hard to believe that it's that much, but you know, if it is 10%, that's a significant improvement. Now, if you look at like a Falcon 9 launch, there might be like 10 or 11 seconds where there's no boosting going on. So it's just going ballistically at that point and not going up. And as it's happening, the vehicle is actually slowing down. So for that 10 seconds, you are slowing back down. And now you have to make it back up when the second stage starts up. So the second stage is basically having to make up what you just lost, and that's your efficiency loss. So with doing hot staging, you're able to do it all the way through. Now, why doesn't the Falcon 9 and the others do the hot staging? Well, part of it is because it's a little bit tricky. And in order to do the staging the way they have it, is you need to have these ullage motors that before you light up, you have these smaller engines, which will give you a little bit of push to create a little bit of an artificial gravity to make sure the propellant load all settles to the bottom of the tanks so you can start pumping it through. And remember, the whole thing that Elon talks about is like the best part is no part. So if you can get rid of the ullage motors, you're going to save a lot of mass and get this advantage. So, you know, it's like a 2-for-1 kind of thing.
But we do
if
have
you're
the
able to
ability.
do it. But there is a mass penalty also along with it, is that new ring they put on there, that's dead weight they're bringing up there. But evidently that dead weight is worth whatever the extra cost is for putting in ullage motors and everything else. And as John was saying, when the booster went back, they had to do something to light those engines up. I think because they have the cold gas thrusters, that may be enough for them to be able to do the ullage that they need.
Well, I think if we look back at the video, I don't think they ever stopped thrusting.
I think they went off. Yeah, let's take a
did
look.
they? Because if they does Super Heavy even have ullage motors?
No,
Like,
it doesn't
if we
have
go-
ullage, but it does have the cold gas thrusters, and so that could be enough to be able to do the trick.
Okay.
Maybe.
So
if
yeah,
you look
you
at
go
it,
to about 3.5 minutes on the clock, the T plus 3.5 or so.
yeah,
Sorry, little thing at the bottom.
we'll see the graphic. The telemetry shows. That
Yeah,
the
we
engine
should
shut
see
down.
it, whether it
So
actually.
you went from 33
Come
to
on,
3. Yep.
Okay, wait.
you got to turn off the sound on that.
Yeah, I'm just trying to play this. Was it Donald was asking if we can play it frame by frame on the launch to see if the pad stays strong?
Yeah. Okay.
Sure.
Can we do that?
Good. Yeah.
Sure.
So wait, if I play it, I don't know how to.
Get off the tower.
3,
Get off the tower.
2,
Your system.
1.
Yeah, just turn off. Come on. Turn off the tower. Come on, baby. Get off the tower.
Okay.
Yes.
It's pitching just a little bit, which I think is intentional at that point. They usually pitch
Yeah,
really
10
close, pretty
seconds.
soon.
Herbert, if you can turn the sound off on the live stream, just kill the, like over on the left, on the bottom left. Yeah, kill that. Thank you. There we go. So it was what, about 11 seconds, which is how long was it last time on the last launch? It was.
Well, yeah,
wasn't
we
that
need to see, usually it takes 6 to 8 seconds. Well, for a Falcon 9, it's about 6 seconds to clear it, but that's not including the fact that there's still a few seconds before it jumps off, because as the other John mentioned, that T-0 is not necessarily when they get off of there. The engines have been kind of lit, and then there's a few seconds before you get enough thrust.
Yeah, if you go back to
jump off.
T-0, let's take a look at when it actually gets off the pad.
Yes,
like,
when it
because
actually
it
gets
burned
off.
for a little while before it actually got off the pad. So I don't think it's moving at that point.
Yeah,
It
so
looks
you
like
get
we're T plus
ignition.
3.
So you're already at 3 seconds.
Yeah, it's not moving.
I'm going
there.
backwards. Okay.
Yep.
Yeah,
Tell me
so
what
go
to do.
go forwards, because I don't think it's getting
Go
anywhere
forwards now?
until about 3 or 4
Go
seconds.
forwards, yep.
Okay, I'm gonna go forward, frame by frame, going forward.
That's great. That's great.
Perfect. So not moving, not moving, not moving. It looks like they lit. It looks like they lit partial because it looks like there's more engines coming online. And
No, but you can see
then,
on the left here, all the engines are on. That's what the lights are.
yeah, it just looked like there was
what
a
it could be
second-
is that
maybe they just
they're
like
all
brought
on,
them
but
up
not full thrust yet.
Yeah, full thrust. Gosh, when does it actually start moving? Now it's moving.
Now
Okay,
it's
so
moving.
somewhere around 4 or 5 seconds, it starts to move. So it gets out of there pretty fast, considering
That's
how tall
fast.
that sucker
That's
is.
fast. It got
Yeah.
out of there in, I think, 5 seconds from there.
That's crazy.
And yeah, and it's much taller than a Falcon 9. It takes Falcon 9 that amount of time to clear its tower.
Right.
Woo! I'm tired pressing the button.
Yeah.
And the other thing, remember, it was probably only 80% thrust because they don't have a payload. They don't need the full one. So I think they're running
Right.
it at the normal thrust to weight ratio. And they didn't want the engines to really be 100%.
Okay, so
And of course, they
the-
didn't see any debris or anything.
Yeah.
I wasn't looking too close down there, but it looks like the deluge system did quite well.
Yeah.
the
Yeah.
pad was fine, right? It looked like, I mean,
It
they
appears to
didn't
be,
show
yeah.
it.
It
Will
appears to be fine.
Will said something very interesting. He said last time here the ground shook like an earthquake. That
Oh.
you could actually feel it. So I mean, anecdotal, but he just told me about that.
No, I can believe it because remember, all that concrete was being busted apart. So it was
Right.
probably like, banging
yeah,
on that, and you were going to feel that through it, which is amazing because given how sandy everything is around there, you shouldn't feel an earthquake because the sand is just going to kind of absorb all that.
Yeah.
But what I think happened is the deluge system did such a good job of maybe capturing that energy that you weren't going to quite feel that same earthquake.
How quickly did it get off the pad?
5
I think
seconds.
around 5 to 6 seconds.
Yeah.
Okay.
After it
6
actually
seconds.
started moving.
Well, cleared the
Yeah.
tower. It cleared the tower. So it was like 5 seconds sitting on the pad, and then another 5 to 6 seconds to clear the tower.
Gosh.
Right. But I think you could see from the flame that they definitely were ramping it. It wasn't like they didn't have full thrust instantly. So I think they were being a little extra careful and wanted to like bring the engines up to full thrust. You can't just start them. It's like, it's basically an explosion if you start it too hard. So you want to bring them up gently and have them burning instead. Xander, that was a great shot. Look how good that was. That was just like so awesome that just like the cocktail you're getting out of there.
Thank you. There was an attempt.
Yeah, no, it's beautiful.
That's
See
nice.
that shot right here? That's only from
Yes.
Xander. That came from
Yep.
Xander. I flipped there. They did not show that.
Yep,
Yeah,
yep.
There's
exactly.
Xander.
Oh, cool.
Yeah, you got all of it.
Oh, nice. Very nice.
So I guess so it wasn't the methane. It's not the methane burning. It's only the contrail because it's only that certain spot in the atmosphere
Yes.
where it did it. So yeah, after it gets out of there,
I
it's
did that.
clean.
I did that.
Xander Sky scam. Yeah.
That's so amazing. Wow.
What else did you want to see? Can you see this?
Let's
the actual
watch
shuttle?
the stage separation when we get there. It's about
Yes, frame by frame is
3
same.
minutes ish, somewhere around there.
Two and
So
a half
we can just
minutes
keep
or what?
watching. Yeah.
Okay.
It's very late because I think Falcon 9 is 2:20 or 2:30, depending.
Yeah, around 2:30. Yeah.
Yeah. And I want to watch like right at stage separation if the booster actually stops thrusting for any time or if it just like continues to. So we can go back and break it down.
Yeah. If both
5,000
if both of them, booster and the Starship, blew up, that's if only one. I was hoping that the Starship wouldn't blow up.
Yeah. Well, I don't know why
So they're
the
shut down right now. Pause it.
Pause it. Wait. Pause it. Yeah. Okay.
Okay. Oops.
Oop.
Oh,
What happened?
unfortunately, you
All
said
the
it
way
back
back.
at the beginning.
Okay. Sorry. Where am I going again? 2 minutes.
T plus 2.5 minutes or so.
Yep.
Sorry, guys.
T.
Yeah, just right there. And when they
Right
show
there,
the
yeah.
shot. Oh, wait.
Okay, so now you're
there-
seeing the graphic of it shutting down. So we
Yeah.
have 3 of them.
Yeah, I paused
Okay,
it.
so now you can go frame at a time through here. Sorry about the button
Ah.
fishing.
The button.
Now the second
So
stage,
we should see second
looks like
stage
it's kind of
kicking in.
coming on, at least in the graphic. but it's maybe not full power. I'm not sure why the telemetry is kind of showing gray there, but we're not really seeing any light that I can tell.
Right.
So it might
It
be
is
that
not
it's like
accelerating
engine
anymore. Look at
chill,
the
or it's getting ready.
5572. Oh, it's actually decelerating.
There we go.
What's going on? What's happening?
Okay. So still thrusting. That's a beautiful shot right there. Wow.
Okay, so now they're lighting up the upper stage.
Right. Oh, that is just what a pretty shot that is with the halo coming around it. Wow.
Yeah, that's coming
So
out of
the
the ring.
telemetry is behind, obviously, because it doesn't
Yes.
show it on.
And the way that it's separating, it's because it's coming through the ring.
Yeah.
Yeah, it's coming
it's
through the ring, and
beautiful.
at some point, it's gonna push back on the booster. So
There it
now
is.
the booster is pushing front. Okay, so
See,
now
the
they
booster
separated.
never stopped thrusting. It's just stays on. So that's
Yeah.
how they keep it. They don't need an ullage motor. In
Now
that
you're getting
case.
some weird telemetry there showing motors that are not on. We can see all 6 on the second stage are going fine.
Right.
Yeah, it's still, you're right. You still see a little bit there, but we can't trust
Okay.
the telemetry at that point.
Yeah.
I got tired button pushing. Should I just play it?
But I don't
Okay,
think
now the
I don't think it
telemetry
ever
shows
I don't think it
us
ever
the
stopped. I think it keeps thrusting, and that way it's able to keep the propellant down at the bottom of the tank.
Yeah. See, that's a really tricky maneuver because
Yeah.
it's trying to push the whole stack up to keep it going for the ullage. And then as soon as you get the separation, the problem is it can then come back and hit it again. So
Right.
the second stage has to get out of there really quick, and you have to make sure that the booster doesn't take off, because suddenly now the booster is lighter again. So you get that separation, and then it will come back. So what
What's
they may
happening-
have to do is throttle down the center engines from whatever they were at down to the minimum. And I think they can only go down around 40%.
Right.
And it's a very tricky maneuver to be able
So
to get
they
that
actually had all 6 engines, though. I mean, on the Starship,
right. Yeah, we
lit them all.
weren't sure if they're going to go with all 6, and they went with all
And they
6
lit them
because
all.
they want to make sure they get that separation.
So the other thing that is possible, we were seeing some really weird behavior on Starship at the very, very end of the whole thing. I wonder if there was some damage. Because think about it, those engine bells, the vacuum engines especially, are huge. And they're probably right down there next to the second stage or the boosters, whatever that heat shield is down there.
Yeah.
So it could have had
there's not much
damage
room.
from that.
There's very little room for those in there.
Right.
And you get a lot of overpressure in there. Just think
Or
about it.
even
It's
the
like the first
particulates,
launch
you know,
all
like
over
you got
again.
hot gas coming out and bouncing like that. So yeah, it could have.
Yeah. So you basically the same problem that you had on the pad the last time. Who knows what's going on?
Oh, so they're going to put a water deluge system in. That's what they'll do.
Oh, they'll do that next.
The second stage, there'll be a water deluge system. And by the way, I am not serious at all, because water is about the heaviest thing you can carry up to orbit. So
Yeah. And now,
you don't
of
want to
course, if
carry
you look at the
much water.
tanks here, you see they're depleting exactly the way it's supposed to. The last
Yes.
time, remember, they were out of sync, which told us, oh, they've got a big leak somewhere. Something's going
Yeah,
on.
exactly.
So, I mean, it looked fine. There was nothing from the telemetry that would indicate that there was any issue about to come
Yeah.
up.
What's that? Is that normal? That part right there?
That
Maybe
there is
not.
not normal, because at that point, it's
Yeah.
not quite 100 miles up. What the von Karman line is 75. So there's
Right.
no atmosphere up there. There's
Yeah.
nothing that should be causing.
So it was going along fine, and then right
At
there,
a guess, it's
7 minutes.
becoming engine rich. The guess would be it's becoming engine rich. It's starting to eat at least one of the engines is starting to get
More
eaten.
than likely, yes, exactly. That's probably a good thing, that one of the bells is starting to be eroded.
But I mean, it still keeps
You
going.
see, it's asymmetric. It's almost like it's on
Yeah.
one side. So one engine is starting to have some problems, because if that was like a normal jellyfish, you would see a perfect cone.
Right. And also, I don't think you get jellyfishes that high, because they're completely out of the atmosphere at this point. So it was burning clean because it's methane. So whatever we're seeing is not clean.
Yeah.
So
With
burning.
the jellyfish, the reason you're getting a jellyfish is that there is no atmosphere, and the atmosphere that's being created is the exhaust plume.
Yeah. Okay, but the way that the announcers, the presenters talk, Kate was saying that they still thought maybe it survived because they just lost the telemetry. So
Right.
But you just told me, by looking at this, you can see that something's really wrong.
Well,
this is not.
it's
supposed
in
to
real
happen.
time. We didn't notice it either.
Yeah.
So,
I mean, the main is, if you're going with the telemetry that's showing it's it's nominal at that point as far as the velocity and altitude. It's right where it's supposed to be.
Right. Okay,
And
pause
then
it
they
right
thought,
here.
oh, we just lost contact. There's something wrong with the ground
Yeah.
stations. And then John came right on out and just said, nope, it was the FTS.
Yeah. So sorry, if you go forward just a little bit, right? If you look at the speed when it gets up to about
Forward.
23, which is really
Here?
fast, and pause it.
Forward here.
Yeah, just go
Yep.
forward. Because you can
Uh,
see how it's I don't even know what the G-force is right now, but that thing is accelerating really fast right now. It's at the
Mhm.
end, you know, it's empty tanks. It's going quick. So it's just around the time it cuts off and you see the engines go out on the telemetry is right after that.
Should
is
I
when the
do
FTS
frame by frame or should I just play it?
no, just keep going. Frame by frame is fine because it happens really fast. I mean, it shuts down at right around 24,000, which is
Mhm.
really fast.
And John,
Sorry
what we're
about
going
the
to do
button pushing.
as far as the frame by frame grabbing of the telemetry, we're having chat do it this time.
Yeah.
That was too tedious last time. So you've got to set up something to go in and read the telemetry. and make a
So we
spreadsheet,
don't
and
see
then we
it
can plot
anymore.
it.
Is that why don't we see it anymore?
It may have shut the video and the telemetry are not necessarily synced.
Correct.
So it's possible.
Correct. They've been off by
Yeah.
quite a bit.
Yeah.
So we saw those, the telemetry of those engines coming up many seconds after we could actually see it visually.
Right. So it should happen
the-
really soon after this.
Now their telemetry is obviously more real time than ours. They're taking whatever's coming in and they're
Right.
composing the
Yeah,
whole
'cause
thing together.
They're saying the
Everything's out
speed
of
is
sync.
still increasing.
Yeah,
Yes.
which
Yeah.
it should
Yes,
be.
it is.
I mean, it's probably
Yep.
still operating at this point because we'll see the big poof that happens in just a second.
Okay, what's
It's
that?
after this, after that piece of booster comes down.
Oh, that's a booster.
Oh
okay.
wow, yeah, that might have been the oof.
It
Oh, my
probably
goodness,
was.
yes, it was. So a piece of booster was way up there coming out there.
Took a little while. Okay, so it's going to
But-
shut down, right? Like
I'm
really
button pressing
soon.
like crazy. Nothing's happening.
There it is. Right?
Okay,
Okay,
shut
so
down.
Keep going. Keep
You
going.
see, it's officially shut down.
Yeah, but then you'll see the poof like that happens just a little bit later.
Even though it's interesting,
Right
the
there,
velocity
right there.
is going up. Even
There.
though
No,
the
right there.
engines
You
are
What
can
are
up.
we
see
s-
it. You can see it.
Yeah, what is it? What are we
That's
seeing?
that's the RUD. I mean,
That's the RUD.
FTS. Just if you
The next frame, you're
play
going to
it
see
back
it.
a little bit, you'll see it. It's
Yeah, I don't
pretty-
want to play it back.
Okay, go
I see
No,
it.
no,
forward.
no.
Just
Just
keep
go
going
forward like 1 or 2 frames.
You can see
Yeah,
it.
there we
It's
go.
just very subtle.
That's where you see it right there.
Yeah,
There's the RUD.
yeah,
That's very clear.
yeah. So, and that's when it says acquiring signal after that. So, wow.
Okay,
Pretty
well, I'm going to
cool.
play it now.
So, yep, that's it. It's done.
Woo.
But-
Yeah, I went from a space jellyfish to a blowfish.
That was
All right,
fun.
guys. So, tell me again. Okay, so what do you guys think? Just let's go through it. Scott, successful, not successful? Just give me a summary. Humanity's moving forward.
Yeah, it is. I mean, it's a little bit disappointing that the second stage didn't make it up there. They were expecting that the booster was probably going to run. So that's not as, and that's why they're trying to learn how the hot staging is going. So a little bit disappointing. I mean, it's successful in that they made it to the hot staging so they could get the data there. Because remember what Elon said last time, it's true for this one, is that the payload is data. That's it. I was a bit surprised that they said we're not going to try to retrieve any, the boosters if they make it back on down, because I would think you would want to do an engineering analysis of that ring and everything else to see how well it did, so you know whether you would be able to reuse it or something like that. But maybe they kind of felt like, it's not going to make it. So in which case I was surprised that they really wanted to get the actuators repaired, because they could have launched without those actuators. The actuators were really just needed to make sure they could do a soft landing. So it meant they had maybe a certain amount of confidence that they would be able to get to that level. And if they could, why not recover it? So it's disappointing that the second stage didn't make it all. But again, they are stressing that they had all these failures in Falcon 9 with all the landing attempts, and they're not failures. What they are is they are a data point. Thomas Edison had tried thousands of materials, which a reporter tried saying, oh, so you had a lot of failures before you got it right. And Edison was like, that was not failure. That was getting the data you needed to be able to find out what is going to work. So disappointing, not a failure.
Yep. Do you want my take or
Yeah, of course. Please,
Okay.
yours.
So I mean, I agree with Scott. Of course, from a personal level, it's like I wanted to see it get into orbit. I wanted to see it come down. I wanted to see shots from the boost. You know, I was sad that I didn't get to see the visuals of it going up. But anyway, hopefully they've got some of that stuff. It's just somewhere. I think very successful for what SpaceX wanted, because they got to the hot staging. They had, it appears, I mean, I don't know because we haven't seen the launch pad afterwards, but it looked like the launch pad, everything survived way better than last time. So huge, big thumbs up for that. Second of all, the hot staging actually functioned and it worked. And that's a huge step forward. And then they basically got to orbit. Now it looked like in retrospect that it was starting to burn through at least one of the engines as it was doing that at the end, which was why we were seeing stuff, because we shouldn't see it. Methane burns clean, so we shouldn't have been able to see anything except for a little bright dot, right? But that's all we should have seen. But clearly something was going wrong, but it got to orbital velocity. I mean, or as close as they wanted to for that. So that's hugely successful. The big thing in my mind is how fast can they launch the next one? And that's partially up to SpaceX. How fast can they iterate, change the designs, whatever they need to do to fix it. And the second part is, permitting. So hopefully the FAA and the National Fish and Wildlife Service are working closer. So everything is like a process, and hopefully they're figuring out how to make this work better. This didn't have the flight termination system, by the way, it's hugely successful. When they fired that flight termination system, that thing went, it didn't do its thing where it flipped around for 40 seconds and didn't terminate. So that was also very successful. So I would think that permit wise, they should get, because the launch pad didn't break up as far as we could tell. And it sounds like Xander said there was less sound. So that's also good because the deluge system worked. And the flight termination system worked. So hopefully they'll be able to launch as soon as SpaceX is able to launch. The deluge system.
So how many Starships do they have? And then how quickly could they do the second trial, the next one?
It depends on what they learned.
Yeah. They have a warehouse full of Raptors, which, usually that's what's going to be limiting. So they could probably, if they wanted, be ready to go in January. If they wanted,
January.
Okay, because they've got so many of them to set up there, and I kind of agree with John that what's really good about this is I think from the regulatory standpoint, there's not going to be this big investigation. There's not going to be this hue and cry. Oh, we got to go in there. So still a little bit premature. We have to make sure the deluge system works exactly as it is. There's going to be a review. The review might go really quick when they realize we can't find anything wrong. There's like no dead sharks coming up along the shore, anything like that.
Dead sharks everywhere.
Seems to be fine.
No, but in terms of SpaceX themselves, both blew up. So how are they going to find out what to fix? If it was just one, they can really focus on that project.
Oh yeah, I'm sure they've got enough teams to go after both. They probably have a booster team and a second stage team, and hopefully.
And we didn't see it, but they have massive amounts of telemetry coming down from these things. So up until the second one they terminated, they have all of this data. So even if they can't collect the physical objects, they know what happened. Yeah, it's like the Falcon 1. If you go back to that, when the Falcon 1, the second stage or the first stage hit the second stage, and I think on the third launch and bumped it and caused it to, they'll know all of this stuff. They don't have to see the physical objects because they have just giant data streams, which is what everybody at SpaceX is probably doing right now, is looking through all that data.
And they probably had other cameras out there as well, things that we haven't seen that will eventually become public.
So
hopefully.
this is Starship. This is what's going to take us to Mars. But the first project would be to go to Moon, right? When is that project? When is that flight? I don't know.
Before 2030.
Oh, come on, Scott, please, buddy.
Seriously, because it's like there's all these delays and everything else, and everyone's waiting for something. So we wanted
to the moon.
Already be doing it by
to the moon.
Yeah, to the moon.
Come on.
I didn't say 2030. I said before 2030. Okay, because there's been delay after delay after delay, and because it's not just waiting on SpaceX; it's also waiting on the SLS and all that. So, is it next year? Within the next 12 months, we're going to do the flyby.
There's a dear moon.
Yeah. Well, dear moon. I'm not sure when that's going to happen, but you're going to get the flyby, and then you're going for Artemis 3, which I think is supposed to be the landing, but the landing just depends, that's much harder than doing the flyby. The manned flyby is
Right.
fairly simple because you don't have to worry about getting on the surface. Now they're trying to come up with a lander, and you're going to have the gate. It's like there's just so many ways that they're trying to do it. The architecture just does not make it easy to say that, oh, by 2026 we'll be ready to go. So it could be more like 27, 28 before they have, because it's NASA. Now it could be that SpaceX figures something out and it was like, well, we'll just go ourselves at some point,
Right.
because, but in order for the SpaceX system to work, they need to do orbital refueling. So that means they have to be able to have a good cadence of these things. And that also makes it a bit more complicated.
Yeah.
Now,
I have a very strong feeling. I don't know about landing on the moon, but getting to the moon, it's going to be SpaceX themselves before NASA. They're going to do a circumlunar. Somebody, one of the people commented, I noticed they'll do a figure 8, just like Apollo 8, a free return trajectory. They'll go out, they'll loop around the moon, they'll come back. That's going to happen prior to NASA doing it.
Yeah, but the problem is because of what happened today, you're going to have to do yet another test before you can actually decide to do that.
But they can iterate really quickly. Like I say, they have a warehouse full of Raptors, so it's not like that's an issue. And everything else is being put together. They've got so many. I mean, the rocket garden is just full of them because they're pumping them out so quickly. So they're working on mass production. They're going to learn a lot. They could do a lot of launches next year if they really wanted to. It's just going to be the permitting that limits them to, what is it, maybe one a month or something like that might be the maximum that they could do.
Right. So it's really, the big thing is, if there was some damage to the launch area that we didn't see, that would be a big deal, because then there'll have to be another investigation. If the deluge system worked well, and no damage really, then hopefully the permitting will be a pretty automated thing. That'll just be like, yep, you can do it again. So it's all about how fast SpaceX, the thing to watch, the metric to watch coming in the next coming months is how soon do they launch again? So the last one was 420, it was April 20th, and it is 11, so 7 months. That they can't launch at that cadence. It's just too slow for them to be able to iterate fast enough. Because as you said, Herbert, I mean, it didn't make it, right? So we've got to, they have to be able to do, at a guess, maybe one more launch, maybe 2 more before they actually get everything working properly, and not the re-landing and stuff, but just to get it to orbit and to do its thing and re-enter in the proper place. So they need to just be able to turn these things around and launch quickly. That's the big thing.
Okay. First of all,
real quick, you said one time a month. Is that SpaceX limitation or regulatory?
Regulatory.
Yeah.
And it may not even be that often. It's not like they can just launch every couple of days if they want, like they are at the Cape. So,
right.
But
there's going to come a time. While they're in the experimental stage, no, but there's going to come a time when they're going to start doing most of their launches from Florida, just because of the fact that the permitting is going to be so much easier. The whole Space Coast is already designed for this. So their tower is far enough away from, they basically have to prove that it's not going to blow up on the pad and damage all the other towers around the area. But once they've got that data, I have a strong feeling, but of course they're going to have to barge things. It's going to be a pain in the butt to get stuff from Texas over there, but it's going to be easier for them to do that.
Too bad, because you don't have to go through any canals.
Yeah, so they'll go around the tip of Florida and up the coast, and then they do have a barge, right where the Falcon 9
unless they
comes
boost
in.
over to there, which is, you never know. They could potentially do
that would be pretty freaking cool.
Yeah.
Hop each one, stack them.
Austin Bernard just posted the mock diamonds. Herbert, can you pull that up?
What's that?
Go to X and type in Austin Bernard. He's an employee.
Oh, did he post a picture of it?
Yes.
Ooh.
Yeah, I think I've seen some of his pictures before. They're outstanding.
Yeah, we're too busy talking.
What is his name? Austin.
Austin Bernard.
I'm looking him up. I don't see him.
Yeah, I don't either. I think I.
All right, hang on. I'll see.
Is he the Justin Bernard?
Maybe. I just saw it come across the top of the screen. So, is it Justin Bernard? It's probably that.
No, that's a football player.
Okay, hang on a second.
I've got a nice update on X from Elon going like Starship launches in 6 hours. So
It's Barnard with an A, Barnard.
Yeah, like Barnard Star.
Oh yeah, there we go. Oh yeah, we follow each other. I was like, I knew I'd seen his name. So, is it one of his posts? Oh,
I think
Oh,
it was
that's a
just
pretty
now.
shot.
Can you see my
Yeah,
screen?
I didn't even see it.
No, not yet.
No, not yet. There
Okay,
we
it's
go.
coming.
Mega
looking
mock
at?
diamond. Yeah, that's cool. Nice,
What does that
Austin.
mean?
What
does that
The
mean?
mock diamonds are the speed of the exhaust coming out of the rocket engines. So they're transonic. Basically, you're taking hot gas in the combustion chamber, and the bell of the engine is designed to take that hot gas that's moving relatively slowly and cool it down and get it supersonic. So the mock diamonds are essentially it's like they're interacting
Basically,
with the
it's
atmosphere.
what you're seeing are the shock waves. The
Yeah,
supersonic
shock waves, yeah.
that are
There we
being
go.
created
Thanks.
in the exhaust plume.
That's a better way to put it. So
Okay, gotcha.
yeah,
And
but
before-
anyway,
before-
that's just beautiful.
And there's apparently on the takeoff, there's a zoom in of someone showed it to me as I was leaving, and that is like ridiculously beautiful. So that we'd want to find
I think
that.
if you go up one, actually, there's one of his posts also was that it's right after. Let's see, where is that? Oh yeah, it's right below the one of him pointing up at the Starship.
Is that? Wait a minute. Was that?
No,
sped up?
it's like it's 59 minutes ago. It
No,
was
no, no,
actually with
what-
John Krause. It was John Krause. He reposted a John Krause shot that's
No,
absolutely stunning.
that video that we were looking at, it looked like it was moving pretty quick.
Yeah, yeah.
I don't know if it was sped up 2 times.
Which John Krause is it?
Not with just with the S, not with an E.
Yeah.
Yeah, it's I think I can't tell whether it's the first shot of his or
If you go to the upper right corner, I think it was showing his media. His recent
No, keep
media.
going, keep going. Scroll down more. Because I think it's like gosh, where is it? Austin had
Actually,
reposted it. It's a I don't know if I can share my
If you
screen.
actually go to the top of his page for just a second and go to the upper right corner, you're going to see everything. There we go. See the
Yeah,
upper
yeah,
right?
yeah. Go to the top right
Yeah, go
corner.
up. Yeah, go to the up. You can see everything. Okay, there's
There
all
was
his
another
images.
one though that's just it's a launch pad one, which is even. Can I share my screen or not? I can't tell. I don't
Yeah,
know.
probably
If
if
I
you
can.
go to his media, you'll see everything.
Yeah. Down, one more. One. Oh no, keep going. There it is. That's
oh,
the
there
one.
it is. Yep. And
Isn't
you
that
get a nice
beautiful?
walk time in there.
And you can see that there is the atmospheric overpressure there. You can which is why it's kind of tucking in because you have to compromise with the engine bells. They have to sort of be a middle ground. And so at sea level, they don't have ideal thrust because they're slightly under the pressure of the atmosphere, which is why you're seeing that kind of hourglass looking thing happening.
Right. And then when you see it go up, you see the plume get wider and wider
Right.
and wider, especially when you get
Right.
up towards max Q.
Yeah. It's really, really, wow, what beautiful shots. Man, some talented people out there. And Xander, I was like, that was super impressive. I'm sure you're going to go back and look at all your video now, but it's going to be like pretty cool to be able to see it all. So yeah.
Yeah. Thanks for having me. Nice to meet you guys.
All right. Yep. So
Great.
first of all, thank you everybody. Appreciate you watching. So we have Scott Walter. He's an aerospace engineer. He's got his website, follow SpaceX Forever. Dr. John Gibbs. He also has his YouTube channel, Dr. Know It All. So lucky that both of these guys were here to give us commentary because I know nothing and I've learned a hell of a lot. And then we had Xander Sky. It's on the ground, saw video. You didn't see that anywhere else. So thank you, Xander, for taking care of that. Thanks, everybody. See you
Yeah.
next
Thank
time.
you.
Thanks, guys.
Super. Thanks, guys.